This is the tutorial for Chapter 5, Section 3, the second day on slope-intercept form. So today we're going to actually graph equations using the slope-intercept form. So the first thing I'm going to do is try to pull out what the slope of the line is and what the y-intercept is. So we used m for the slope, and we see the slope is 1. So remember, the slope-intercept form goes y equals mx plus b. So the number out in front of x is going to be the slope. If I don't see a number, it's 1. The y-intercept, I'll use the variable b to represent that, and that equals 3 in this case. The y-intercept is what adds to the x term. So I just go up 3 spaces, start at that point, and then use the slope. It's a 1-to-1 slope, so that means you're going to go up 1 and then over 1 to the right. Again, what slope represents is the change of y over the change of x. And so it's always whatever number would be on top of the fraction, if I wrote that as a fraction, 1 over 1. In this case is how you could write 1 as a fraction. The top number represents how much I go over, or how much I go up, and the bottom number, the denominator, represents how much I go to the left or to the right. And so that's going to be the line. I can continue it out going in the other direction as well. So I'll have lots of points to be able to draw a nice line through. So the next one, I see y equals 4x minus 1. So the slope of the line is 4, and I'm going to write that as a fraction, 4 over 1. The y-intercept is negative 1, and I'm going to start at that point. So once I put that point in there, I use the slope. Again, it's 4 to 1, so I go up 4 spaces from that point. So up 1, 2, 3, 4, and then over 1 to the right. So up 1, 2, 3, 4 over 1 to the right. I could do the same thing going down, 1, 2, 3, 4, 1 to the left, because down and left would be a negative 4 over a negative 1, and that's how it represents the same thing as a positive 4 over positive 1. So you can always go down to the left as well for that line. So you draw a line between those points, and we've got our line. So y equals negative x plus 6. The slope of the line is negative 1. Y-intercept is 6. Again, you can write that negative 1 as a fraction, as negative 1 over 1. So we're going to start with the y-intercept, a positive 6. Use the slope. This time it's down, because it's a negative 1 there. Down and then to the right, because it's positive. So down to the right, down to the right, down to the right, down to the right. Now you could go the other way. I could write that slope as 1 over negative 1. That would tell me to go up and then to the left. And you'll see how you get to the same point, or same line. See, if I go up and left, that puts me right there, which is on that line that I end up seeing there. So this one we have to solve for the y form. So the first thing I'm going to do is distribute that 1/3. And so I've got y equal, or y minus. So y minus 5 equals 1/3 x minus 3. I got the 3 because 1/3 of the 9 is just 3. From there I just need to add the 5 to all sides, and you'll see how you get y equals 1/3 x plus 2. So now I'm ready to go ahead and figure out the slope and the y-intercept. So here my slope is 1/3. My y-intercept is positive 2. So I'm going to start at positive 2, use the slope. This time the slope is 1, which means go up 1 and then right 3 spaces. So up 1, right 3 spaces. Up 1, right 3 spaces. I can also go the other direction. Remember, I could represent that as a negative 1 over negative 3, which would multiply or divide to make a positive. That would tell me to go down and then left is what that tells me to go. So down 1, left 3. And you can see that because in the negative direction's going down, and you see these negative numbers down here, that tells me to go, that those numbers are to the left. And you see that ends up getting on that line. So we can go ahead and draw it between those points. So same thing here, I need to get y by itself. So first thing I'm going to do is move the 12x over in the 6. So you'll see how I end up having to add this 12 and subtract the 6. So I now have this equation. I've got 3y equals 12x minus 6. And so the signs just switch, and when you move something to the other side of the equal sign. So I'm going to go ahead and divide by the 3. You got to divide every number by 3. So when I do that, my new equation is y equals, and then I've got 4x minus 3. So you can see how 4 is the slope, and I can treat that as a fraction. It's 4 over 1. So I'm going to go down 3 to start with, and then I go up 4 spaces, and then over 1 to the right. up 4 spaces, 1 to the right, and that gets you on that line. You could also go the other direction, down 4 and left 1. See how that gets you on that same exact line. So draw the line a little better than what I just did there, and with some arrows at the end signifying it goes on forever. So on this one, I'm going to bring the y over to this side. See, if I add y, that gets y almost by itself. Then I'm going to subtract the 2, and I've got this. So I'm going to rewrite it with y on this side, though. Y equals 1/2 x minus 2. So 1/2 is the slope, -2 is the y-intercept. So I'm going to start down at -2, and then just use the slope. So the slope was 1 to 2, so it tells me to go up and then right is what that tells me to do, because they're both positive directions. So up 1, right 2, up 1, right 2, up 1, right 2. I can also go the other direction, so again, I can use the slope of -1 over -2. And that represents the same slope because the two negatives would cancel. So that would tell me to go down and then to the left 2 spaces. So down 1, left 2, down 1, left 2, down 1, left 2. Once you got a bunch of points, you can see how they're in line with one another. You can draw the line between those points, and you've got your line. So we're going to use that concept to graph. It works really quickly, quicker than you could put it into a calculator or come up with values of y from values of x. So let's take a look at some other problems that we'll see. Here we've got a couple word problems. It says Hudson is already 40 miles away from home. So 40 miles away from home, and on his drive back to college, he is driving 65 miles per hour. Write an equation that models the distance d traveled after h hours. And what is the graph of the equation? So we're going to start with trying to write the equation. So we'll start with the 40 miles. So he's 40 miles away from home, and he's driving back to college, so he's going away from home even further, and he's driving at 65 miles per hour. So whenever you see this, this represents a rate, and a rate is going to end up being our slope of a line. And so we're going to write this as 65h. H represents the number of hours, and d represents the distance. So this is our dependent variable. So the distance depends on the number of hours. So this is our independent variable. Independent. And from there, we can go ahead and graph it. So I'm going to put h over on this side, our independent axis, and I'll write down hours here. And then this is our dependent axis, and that represents distance. So we'll write distance from home. And we're going to start, I'm going to go ahead and use, let's go ahead and, we've got quite a steep slope here, 65. And so I think I'm going to go ahead and start this with I'm going to go by 20s, I think. I'll go, we'll say this is 20 here, and then we'll go and call this one 60 here, and so on. So it's 20, this would be 40 in between, obviously, 80, and so this would be 100. And we've got 120, so this would be 140, and 160, so this would be 180. And so I'm going to go with my hours. I'm going to spread those out just a little bit because I've got this going so steep. If I went only like 1 or 2 hours, I'm going to be already off the graph. So I'm going to call this maybe like 1 hour here, and I'll put 1 hour right here, and this is 2 hours, and 3 hours, and 4 hours. So I'm going to start with where we are, 40 miles already away from home, and then at 65 miles an hour. So we got to go 65 miles up. So this is going to end up being 20, 40, 60, and then 5. So 60, 70 will be right there. So it's going to be a little bit lower than that. So it's about right here. It's going to end up being 65 miles now, 65 miles away. And then again, that's going to be 105 miles. And that's about right. You see how that's just a little over. Halfway would be 110. So 105 should be between 100 and 110. And then at 2 hours, well, we just kind of follow it up. So we've got, this will be, let's go with this is 20, 40, 60. and we've got 5, so we're going to be somewhere right around in here. And then after that I'll be off the graph. So the line, you can see, ends up going in this direction. So it is continuous because we can have numbers in between the 1 hour and the 2 hours. So here it says when Phil started his new job, he owed the company. Owed the company means it's going to end up telling us that we have a minus $65. He owed the company $65 for his uniform. So it's a minus 65 to start with. And then his earnings were $13 per hour. So $13 every hour. And they want to know, write an equation that models the total amount of money after so many hours. So we're going to find out how much money he has. So our y-axis is going to be our money axis, and our x-axis is going to represent hours. So we have hours on this side, and this is representing money over on this side. So I have the same sort of situation. I'm going to call this one way down here. Let's see, this is 1, 2, 3, 4, 5. I'm going to go up by 13s. Kind of an odd number, but that represents the slope right here. So if I do 13 times 5 makes 65. So this is going to be negative 65 right here. And then I'm going by 13, so I'll go ahead and write down this would be negative 39, and then this would be negative 13. This would be positive 13 here. This would be 39 here, and so on. So when I start out, we're $65 in debt, so we're right there. And so after, and then we'll call these, but we're going by ones here, so we'll just put 2, 4, and so on. So there's 65, that's the initial, and then after that, 13 hours later, we are right here. And then we continue on, and you'll see that after 5 hours, hey, we're debt-free, we're actually making money after those 5 hours. And remember, this is continuous data because we could work a fraction of an hour, so we end up having a line that looks like that. So those are types of problems that we're going to see on tonight's homework. Good luck.